I now want to look at solving exponential equations, and there are two types of exponential equations. So the first type that we're going to look at, I'm going to call type 1, and we're going to use a very basic rule for that. It says a to the x equal to a to the y implies x equal to y. So type 1 are things that we can write as exponents written to the same base. So let's look at some examples of this. Here I have 5 to the x equal to 125. Well, we can rewrite 125 as 5 cubed. So we have x equal to 3. Making it slightly more complicated, 5 to the 2x equal to 5 to the x plus 1. Here we have 2x equal to x plus 1. And then we can solve. Subtracting x from both sides gives me x equal to 1. So I have my solution. If we have something like 4 to the x equal to 8 to the x minus 2, we can't write 8 as 4 to a power. However, we could rewrite both of these. 4 is 2 squared, and 8 is 2 cubed. So this would be 2 to the 2x is equal to 2 to the 3x minus 6, because whenever we raise a power to a power, we multiply. That gives me 2x is equal to 3x minus 6. We could subtract 3x from both sides. That gives me negative x equal to negative 6, or x is equal to 6. What about this one? 3 to the x plus 2 equal to 7. Well, I can't write 7 as 3 to a power, and I can't rewrite them both like I did in my last example, so we need another method, and this is going to be my type 2 equations. So to solve these, we have a sequence of steps. The first step is to isolate the exponential. In other words, get the exponential on one side by itself. Next, we're going to take either log base 10 or ln of both sides. We're then going to use our properties of logarithms to rewrite this. And finally, solve. So let's look at some examples. Here's the example we had before. We already have the exponential on one side by itself. So the next thing we do is step 2, which was to take the logarithm of both sides. And I'm going to do ln. So ln to the 3, ln of 3 to the x plus 2 equal to ln of 7. We then want to use properties of logs. Properties of logs say exponents can move down front. So we have x plus 2 times ln of 3 equal to ln of 7. I can divide both sides by ln of 3. That gives me x plus 2 is equal to ln of 7 divided by ln of 3. I can subtract 2 from both sides and I have my solution. ln 7 over ln 3 minus 2. And we could type this into a calculator and get an approximation as well. Here I have 2 to the 5 minus 7x equal to 15. Once again, I already have the exponential by itself, so I get to move to my second step. Take either log or ln of both sides. Since I did ln in the last example, I'll do log this time. It really doesn't matter which one we do. So I have log of 2 to the 5 minus 7x equal to log of 15. I'm then going to use my properties of logarithms to bring the exponent down. I have 5 minus 7x times log 2 equal to log of 15. We can divide by log base 2, or log base 10 of 2. That gives me 5 minus 7x is equal to log 15 over log 2. I can subtract 5 from both sides. That tells me negative 7x is equal to log 15 over log of 2. minus 5. And then I can divide both sides by negative 7. And when I do, I get log 15 over negative 7 log 2 plus 5 over 7. And once again, this is something you could absolutely type into a calculator and get an approximation for. And I want to do 8 e to the 2x equal to 20. And this time I'm going to have to do my first step. Divide both sides by 8 so that my exponential is on one side alone. And I have e to the 2x equal to 2.5. Since I'm dealing with an e, I'm going to take ln of both sides. Since I already have an e, it's going to be advantageous for me to do this. An ln and an e are inverses of one another, so they cancel each other out, and we're left with 2x equal to ln of 2.5. We could divide by 2 as I'm solving. We get x equal to ln of 2.5 divided by 2.